G'day chemistry students, in this video we are looking at dot point 7.4.5. Our focus is going to be on reactions that produce alcohols. Let's get into it. Now the first reaction that I want to look at is a substitution reaction, so substituting on hydroxide to a haloalkane. Now there are two different processes which we can follow. One in which we produce a tertiary alcohol, uses a thing called an Sn1 mechanism. It's a slightly different substitution mechanism, but you end up getting the same product. Essentially, you're removing the halogen and putting on an OH. So OH goes on, halogen goes off. With a primary and a secondary alcohol, same thing. You can do an Sn2 mechanism. The result's the same. You take off a halogen, you put on a hydroxide, and that's the hydroxide there, and that's the halogen off. The mechanism that they follow is slightly different though, so I'm going to talk about them separately. In our first example in this Sn1 mechanism, what we see is that the bond between the chlorine and the bromine breaks, essentially forming a positive ion on the carbon chain and a bromine free radical. That hydroxide is then, because it's negatively charged, able to add on to the positive ion, forming our alcohol. That bromine ion can then attach to the sodium that was a part of the sodium hydroxide in this example. So in this Sn1 mechanism, what we see is there is a process to remove the bromine physically and then attach the hydroxide in its place. When we undergo an Sn2 mechanism, what we see is that those two processes actually happen at the same time. The hydroxide is able to come in physically behind, sort of on the other side of where the bromine is, and start to form a bond as the bromine detaches. We end up getting exactly the same product. The difference between Sn1 and Sn2 is very minor and really only is considered or is important once you get to like uni level organic chemistry. But either you can go through a process where you take the halogen off and put the hydroxide on, or a process like this Sn2 mechanism where the hydroxide can actually come in and attach itself to the molecule as the bromine is coming off. In both situations, you end up taking off the halogen and putting on the hydroxide. It's as simple as that. Another process that we can follow, though, is a fermentation process. This is where we take simple sugars like glucose and have them undergo a chemical process in which they break down, forming ethanol and carbon dioxide. A lot of the time during fermentation, we can use yeast enzymes which catalyze this process. The steps and the mechanisms to actually have this reaction proceed is quite complicated, so I'm not going to go into any of those details. All I want to acknowledge is that we are looking at an anaerobic fermentation. Anaerobic meaning lacking oxygen. So you can have some fermentation processes in which you'll have the sugar and oxygen and your yeast enzyme. That can lead to a variety of different products. So what we're looking at here is anaerobic fermentation, specifically to produce ethanol and alcohol. And we're actually going to be undertaking this anaerobic fermentation process in class. Thank you very much, everyone. In the next video, we're going to be looking at a variety of different reactions with alcohols, and that's going to sort of form our basis for pretty much all of our organic reactions. Once we get all of those summarized, we're going to be looking at what we can do with all of those reactions. But until then, have a good one.